Now this slide, it's the only slide in this lecture. The only point of this lecture is to help you recognize the relationship between regression and Pearson's correlation. So remember that R represents the relationship between X and Y. So to the extent that R represents how X and Y are related, everything that isn't R is going to represent error. Okay? So this stands to reason then that a larger value of the correlation coefficient is going to result in a smaller value for error relative to SS total. Also, the proportionate reduction of error is the same as R squared. So if we have the R value and we square it, it gives us our coefficient of determination. So these terms, the proportionate reduction of error and the coefficient of determination, these are equivalent terms, except that the coefficient of determination is expressed as R squared. And it gives us the amount of variance in y that we can explain with knowledge of x. And if you look at this equation for R squared, this is the exact same equation for the proportionate reduction of error. So the relationship between regression and correlation is that when we square the value for the correlation coefficient, we have the amount of variability in the variability in y that we're able to associate with or attribute to differences in x, and that's a very important piece of information. The inverse of the coefficient of determination is the coefficient of non-determination, and this tells us essentially how much variation in y is left unexplained. And so if I take r and subtract the value of R squared, that's going to give me my coefficient of non-determination, and I can calculate that by dividing sums of squares for error by sums of squares for total.